Of worship, yes, of course. Allah gives us prizes, yes. Yes. And like I said, I will give you prizes if you give me the notes for my lectures. So you write notes, even in point form, you send them to knowledgeseekers514@gmail.com. I promise you I will give you a prize for every single lecture note that you give for every single lecture. Okay? Sallu ala Muhammad wa ala Muhammad. So alhamdulillah, we had the tawfiq of going over part of the will of the Imam Salamullah alayhi to his son Imam al-Hasan. Today inshallah we'll go back to our theology series so that inshallah by the time the month of Ramadan is done, we will have completed a complete theology series. And I want you to know that the reason why I offer the theology series when I first come to a community is out of the advice of one of my teachers, may Allah soul Grand Ayatollah Sayyid Muhammad Sa'id al-Hakim. The first time that I ever went to Najaf and I studied and I was going back to Tabligh, to the US, I passed by every single marja, and when I asked them for advice, inshallah each day I'll tell you the advice that each marja told me. Today I told you what Ayatollah Sayyid Muhammad Sa'id al-Hakim, rahmatullah, what he said to me. He said, Aous, when you go out, make sure that you teach them theology. He said, that's the first thing. He said, then encourage them to come to Riyadh. And let's recite Fatiha for his soul. So I promised you that I would address the issue of chaos theory. Yesterday, last night, when we were sitting after the A'mal, some of the brothers and sisters got a taste of this idea of chaos theory. Today we really want to address it. Why? It's extremely important when we're living in the West. Even today when you're living in the Middle East, you'll find that this is also an issue. Why? Because there are people who are propagating to us that this world came out of chaos and came out of coincidence. And therefore it's important for us to be able to differentiate between two terms, understanding how they are being used, and to be able to answer any questions that people may have, or answer and respond to any challenges that people might have when they say, oh, you guys are Muslims, you're creationists, or that the world was created by a creator, but we believe that the world came out of coincidence. What is this coincidence? That's the first thing we'll look at. The second thing is we want to look at the term chaos itself. How is it being used? In layman's terms, how is it used? And in scientific terms, how is it used? And then we'll be able to determine truly if this world came out of chaos and coincidence or not. So the first term, coincidence, okay, is made up of several parts, right? Which means for something to occur at the same time, okay? So just like cooperation, right? Operation is just a simple operation. But when you say that means that there's other people being involved, right? Right? That there's a collaboration, something's happening, okay? So, now incidents. So there's an incident or several incidents that coincide, yes? Okay? So that means then that there's an incident that occurs at the same time as another incident. And so it becomes what? A coincidence, right? Now let's look at the term incident. For an incident to occur, does it occur randomly by itself? Or is it a result of, in the case of humans, is it a result of their own choice? So when you do something, right now you said no idea. When you said no idea, was that your choice to say no idea or no? There you go. So that's an incident, okay, right, that you just said. One of the brothers over there, he nodded. This was another incident, right? And so your two incidents coincided. So that's a coincidence, okay? Now, we usually use that term when, let's say, for example, I go to, let's say, the local, I don't know, Walgreens or something, and then all of a sudden I see you at the Walgreens. And I say, mashallah, what a coincidence, right? But coincidence. It's just that our choices coincided. Does that make sense? So it's not something that's random. It's a result of human choice in this case. Make sense? Let me give you another example. If I want to produce water in a chemistry lab, everybody's taking chemistry here? Has anybody not taken chemistry here? Okay. So in order to create water, what you need is you need a test tube of oxygen and you need a test tube of hydrogen. Yes? Because water is made out of H2O. 2 hydrogens and an oxygen. Agreed? If you agree, say I agree. All right? So in order to make water in the lab, what you do is you fill one test tube with hydrogen. You hold it upside down so that the gas doesn't escape. And then you fill another test tube with oxygen. You hold it upside down. Now, if you put them next to each other, right, and you make the ends meet, right, will you produce water? No, you won't. No. There's something missing. Now, you made the choice of bringing the hydrogen. Yes? And you made the choice of bringing the oxygen test tube and filling it in, right? And you made the choice of bringing them together. So far, no coincidence, even though they coincided in position. But there's no coincidence. Notice? Okay? So the next thing is what? Is you put them together. Nothing happened. Why? Because there's something missing. You know what that is? A spark. Okay? You need a spark. You need a flame or a spark to do what? At the ends, so that you hear a pop. That pop, once you put the spark, okay, you light a lighter, okay, or you use the, I don't know what they call it, jaddaha with the igniter, right? And then you get a spark, and what happens if you put it right there at their ends, the ends of those 2 test tubes, you hear a pop, like a mini explosion. And what comes out? What comes out? Water, exactly. Which means that hydrogen and oxygen cannot react without somebody initiating the reaction. Make sense? Make sense? Okay. So then, that means then, so I want you to keep that in mind. So now let's look, now we understood then how the word coincidence occurs, what it's made up of etymologically. We also found out that this term, how it's being used in, in layman's terms, how we use it in everyday life, right? Okay. So we both went to Walgreens, we saw each other, now it's coincidence. No, we said no, it's a result of human choice, okay? Now, after that, we moved on. We said, okay, well, what about for something to be created? And I used the simple example of water, right? Let's say, for example, if 2 people come, just like the water, they come and they stand together. Will a baby pop out? No, right? They would have to get married, yes? So there has to be a spark, yes? There has to be a spark, right? And that spark has to ignite what? A marriage. All halal, of course. Or all halal, right? Okay? So keep that in mind. Now, this is coincidence. So that tells us then the way that the term coincidence is used in layman's terms, we say in the Hausa, we say, biha tasamuh. Meaning that, it's kind of, it's used in a way that's kind of wide, right? But it creates a misunderstanding. Because if somebody comes to you and says to you, oh, the world came out of coincidence, we say to them, hang on, stop, okay? I took the class, the Knowledge Seekers class, with Sheikh Aous, and he explained to us, okay, that for 2 incidents to coincide, okay, there had to be a reason for them coinciding. If it's humans, then it's their choice. If it's chemicals, then somehow there has to be a reason for them to come together, right? If it's water, then there has to be something that sparks it. If it's 2 people, then babies just don't pop out of thin air, right? Huh? People have to get together. Yes, they have to get married and then have children. Of course, all the halal way again, all right? Now, I want to share with you this story. And this story is a story that I want you to take note of because it's a very simple story. As a child will understand it and an adult will understand it as well, okay? So this is the story of a professor in Sydney. This professor had to give a lecture, a keynote speech, at this conference. So what does he do? That day, he decides to leave towards the conference. But it took him a very long time. His colleagues in the conference kept on waiting for him. Half an hour passed by, an hour passed by, an hour and a half. What's going on? Shi khabar, shil qassa. Where is this guy? Right? 3 hours passed by and he shows up. Yaba, wainak, where have you been? Huh? Where have you been? They said to him. He said, well, today I decided to come to the conference walking. So when I left my house, I walked and walked and walked. I got to the edge of a riverbank. He said, so I stood there and I waited and waited and waited. I waited until all the twigs in the water coincidentally and randomly came together and formed a raft. As soon as the raft was formed, I got on the raft, I crossed the river. Okay? So you can imagine, when they heard the story, What did they say to him? They laughed at him. They ridiculed him. They said, this is ridiculous. How do you expect us to believe? How can any rational person believe that a bunch of twigs can come together, okay, coincidentally, right, and create a raft that's strong enough to carry your body weight and allow you to cross the river? Absolutely ridiculous. Do you agree? If you agree, say I agree. Right? So he said to them, Subhanallah. And yet, this world, with all of its intricate details, right, with all of its complexity, the DNA, the RNA, the chloroplasts, the quarks, the atoms, the electrons, you believe all of that came together out of coincidence, and you want the entire world to believe that it came out of coincidence, and you won't even believe that a simple raft would come together out of coincidence. How does that make any sense? Who should be ridiculing whom? Good story? Yes? Very good story, right? You think you can use it? Easy to remember, right? Not technical at all. So I wanted to give you a story that's very simple. Look, Allah subhanahu wa ta'ala would not make it hard for us to understand these concepts. You don't have to take high-level philosophy, you know, like I did in the house, in order for you to understand these simple concepts. We see in the Holy Quran, Prophet Ibrahim alayhi salam, he sits with those who are worshiping the sun, and when the sun sets, he says, my God isn't one that leaves. He's always here, right? And those who are worshiping the moon, he says the same thing to them when the moon disappears. Those who are worshiping the stars, worshiping the planets, he said the same thing to them, right? My God, لَيْسَ مِنَ الْآفِلِينَ. He doesn't leave. He's always here. Just simple, logical deduction, right? That's all. So this is a very simple story that you can use. Now, that's coincidence. Let's talk about, because when you talk about coincidence, you also have to talk about randomness. And in order to understand randomness, we need to address the term chaos and how it's used. Okay? So this is the second. The title should be chaos now. Okay? Now, when we hear the term chaos, what comes to mind? Who can tell me? What comes to your mind when you hear the term chaos? Someone? Disorganization. Ahsant. When something's not organized. Very good. Everybody agree with that? Yeah? So your mom will enter your room and say, oh my God, how chaotic is this room? Right? Yes? How many times do I tell you, clean your room, organize your room, right? Most of us have heard this growing up, right? Or you go into your office, for example, right? And you see the office, and the office is disorganized. So you say, my goodness, it's so chaotic, right? So that's the layman's understanding of the word chaos. That chaos means disorganization. Agreed? Now let me ask you a question. When your room was disorganized, or your office was disorganized, did everything, like did your clothes move to that place in the floor by themselves? Like did they just move randomly? Huh? Did that plate of food with the sandwich that you had for suhoor that now is molding under your bed, did that get there randomly? Yani by itself it just floated? Huh? Randomly? Or did somebody put it there? Huh? Somebody put it there, right? The little date pits that are under your pillow because you're sleeping and you're trying to get your last bit of suhoor. Huh? Did that go under there by itself? Did it eat itself and put itself under there? Or did somebody put it there? Huh? Or that chocolate, that Snickers wrapper, huh? That's laying under, you know, under your mattress. Yes? Who put it there? By itself it came and walked out of CVS or Walmart and came and put itself under your bed? Or did you put it there? Somebody had to put it there. Do you agree? Yes? Okay. So then this chaos, even the concept of chaos and disorganization is a result of our choices. Do you agree? Yes? Okay, good. Now, we want to look at the scientific use of the term chaos. Because you see, chaos now, we come to understand that chaos is just disorganization. So when we look at the media use of the term chaos, and they say, they're pushing at us this whole idea that the world came out of chaos, randomness, and coincidence. We fixed the whole idea of coincidence, right? We got that straight. Now we want to talk about the randomness and chaos. Why is the media pushing the understanding of chaos as though the world came out of disorganization? Why is that? We'll address that at the end. okay? But I want you to keep that in mind, okay? Keep it in mind. Now, the scientific use of the word chaos. There are two ways that the term chaos has been used. One, in entropy, in thermodynamics. Anybody's taken thermodynamics here? Everybody knows sigma, which is entropy? Yes? Okay. So what's entropy? Entropy is something's tendency to go towards disorganization. That's the simple layman's explanation. Okay? That if something is not organized, it goes to, it's let's say the value at which this thing will go to disorganization. Okay? So that's one usage of the term chaos. It's used as it relates to the term entropy in thermodynamics and physics. Also, the term chaos is used by a man who coined the term chaos theory. Has anybody heard of the term of the term chaos with theory right after it? Anyone? So chaos theory is also the whole term that's being used by the media to push the idea of randomness and the world coming out of coincidence and chaos. Okay? But really, the term chaos theory was coined by a man named Edward Lorenz. Okay? Edward Lorenz was a Harvard professor in the 1960s. Okay? And what he did was he studied atmospheric phenomena. He believed that what we see as random climatic and atmospheric changes, in actual fact, had to be very organized, but he needed to figure out how. So he collected all of the historical data of atmospheric change, and as he tabulated and collected all the information, he was able to find the algorithm by which one can predict atmospheric change. And he called that chaos theory. His intention was not to say that atmospheric phenomena are chaotic, but rather that there is no chaos in atmospheric and climatic change. You with me, or did I lose you? You're with me, yes? Okay? So that means then that in actual fact, scientifically speaking, this man proved that there is no chaos in climatic change and in complex systems that we don't understand because we don't have the metrics or the technology or the science to be able to make such a discovery, to discover what is behind it, okay? But when we do put in the time and we do have the technology and we are able to tabulate our data, then we can find the formula from which we can understand and by which we can predict, right, atmospheric phenomena and change. Makes sense? If it makes sense, say it makes sense. Okay? So make sure you write that name down, Edward Lorenz. Okay? All right. You say, okay, maybe Sheikhna, this is just for atmospheric change. Nope. There's another name. Benoit Mandelbrot. He held 15 PhDs and had Einstein's chair, meaning that he sat in the position of Einstein. Okay? Benoit Mandelbrot, a Swiss scientist. What's attributed to him? What's attributed to him is fractal mathematics. He's known as the father of fractal mathematics. Now, what is a fractal? And how did he come up with this fractal mathematics? In his PhD, he was given the project of figuring out the perimeter or the circumference of the UK. Now, any landmass that is surrounded by water or that borders water is going to be jagged, right? It's going to have really organic-looking edges, okay? And they look haphazard and random. They look like there's no rhyme or reason or organization to them. Agreed? When you first look at them, yes? And we know that these edges are going to be changing as a result of soil erosion, right? As a result of the water, the tidal movement as it hits the side of the landmass, takes away some of that sand. Yes? Agreed? Right? And we see as well, you know, where we have full erosion of like soil on the edge of cliffs when it comes to being at the side of water as well, right? But this is what Benoit Mandelbrot did. And it's based on very simple scientific deduction, first and foremost, okay? And if you're bear with me. Now, the difference between a gas, a liquid, and a solid is what? Is how compact their atoms are, yes? The more compact, so if it's a gas, it's very, very loose atoms, agreed? Right? We're just reviewing some science here, okay? Very loose atoms, right? Okay? But once they come a little closer to each other, that will turn into a liquid, yes? Okay? And then if it's even more compacted, then it becomes a solid, yes? Okay. So now these relationships between these atoms, would you say that they're organized or disorganized? Organized, right? Yes, ahsanti. They're very organized. And they're held together by electrostatic forces, yes? And electromagnetic forces, right? So that means then that whatever movement, when the ocean, which is liquid, comes and takes from the solid earth, right? Whatever it's taking in a form of organization, not disorganization. Would you agree? Yes? Okay, good. So then if you just contemplate over that, that tells us then that since scientifically we know atomic structure and how solids, liquids, and gases are formed, then we should be able to also figure out the algorithm or the formula by which we can determine when liquid hits a solid, and this, by the way, is material science, okay? So if you're a mechanical engineer, you will study material science. Am I right? Do I have any mechanical or civil engineers here? None? One person, okay? So this is called material science. You learn about the stresses that affect materials, right? What affects them, how they're affected. But for us, we don't need to take mechanical engineering to understand this concept. All we need to know is that atoms, right, when they're compact, they're solid, and they're organized. When they're liquid, they're looser, and they're still organized. They're still held by forces together. And the same thing when it comes to a gas, okay? Except they're much looser. So when one comes into contact with the other, such as the liquid, taking away from the solid, whatever it's taking away, it's going to take away in a mathematical and organized and logical fashion. So far, so good? You agree? Say, I agree if you agree. Okay, very good. Now, so where did we get this concept of chaos, before I go into Benoit Mandelbrot? Where did we get this concept of entropy and chaos when it came to science? There's a man by the name of Robert Brown, okay? Robert Brown is the father of something called Brownian motion. Has anybody heard of Brownian motion? So Brownian motion, if you go back into your old chemistry books, you'll discover that Robert Brown took some pollen and he threw it in a bath of water. And he noticed under the microscope that the pollen was moving haphazardly. So what did he say? He automatically assumed that everything is in disorder unless it is organized or ordered. Okay? All right? You got it? So this is Robert Brown. So what was his theory called? Brownian motion. Now Einstein comes along and he says, hang on, this doesn't sound right. So he analyzed the exact example that he gave, meaning Robert Brown, and what he discovered, he said, because nothing moves just, without purpose or without something affecting it, right? We're in a world of cause and effect, yes? Right? Nothing's going to happen unless there's something pushing it to happen, right, in this world. So what happens? Einstein says, all right, I'm going to study this phenomenon. He studies it. What does he find? He found in actual fact the pollen was being bombarded by water molecules at certain speeds. So he determined not only that there are water molecules that are bombarding the pollen, but he determined the actual speed of the water molecules and the number of the water molecules. And it was through this study that he did that we were able to uncover the atom because of his work. Okay? Yes. So now, look, even Einstein is involved in this now. Yeah? So notice, so Einstein determines there is no disorganization or random motion, right? Because the pollen moving haphazardly, this is where we got this idea of randomness, right? And I want to tell you this little story before I move on to Benoit Mandelbrot. I was sitting with a particle physicist. I was giving this series, to a community, and there was a particle physicist in the crowd. After I was done, and I had given this lecture, he approached me. He said, are you telling me there's no randomness? This is what we do. You have a particle generator. We bombard particles, and we depend on, randomness. I said, let me ask you a question. I said, randomness, is it a variable or not? He said, yes, it is a variable. I said to him, okay, great. So what does that mean? It means that you don't know why these particles are moving at the speed and the rate that they're moving. You don't know why they're moving, how they're moving, or you just haven't discovered why they're moving the way they're moving. So he went silent. I said, let me remind you, we're in an age where at one point people believed there was emptiness in outer space. Then we uncovered there was something called dark matter. That it's actual matter. And that matter appears, this dark matter, right? And disappears in different forms, known as quarks. Now, did we know quarks 20 years ago, 30 years ago, 40 years ago? No, we didn't, right? We didn't. But we came to discover it later on. So the movements of these particles, is it truly random, or is it affected by other things? By either the weight of the particle, or by the energy within the particle, or by the fact that it's being bombarded by maybe other particles that I don't see, just like Einstein uncovered. He said, yeah, I see what you're saying. You're right. I didn't think of it that way. Sometimes it's just simple observations that can help you reach certain realities, right? Sallu ala Muhammad wa ala Muhammad. So far we have Edward, we mentioned several names. Robert Brown, who had this mistaken idea that the pollen moves randomly, and so he said everything goes to randomness or chaos unless organized. Then we had Einstein, who corrected his theory, right? And discovered the speed of atoms and molecules themselves. Then we have Edward Lorenz, who's the father and the person who coined the term chaos theory, yes? And then lastly, we have Benoit Mandelbrot, okay? Benoit Mandelbrot, the father of fractal mathematics, what did he do? He had to measure the size of the UK in his PhD project. So he researches, knowing the information that he knows about solids and liquids and gases, he was able to uncover the algorithm, okay, to discover how the size of this landmass can actually be calculated. Now, what he discovered was what? Was that everything comes down to a fractal, basically an instance of something, okay? A small instance. That small instance is repeated over and over and over and over and over until you have that mass of it. So for example, let's take water, right? Remember how we said we had water, hydrogen, and oxygen, then we had the spark, it created the water, right? But in order for the water to be in its form, you have to have so many water molecules, right? A mass, like a good sum of them, which means that you need to have a lot of hydrogens and a lot of oxygens reacting together. But the one instance of H2O is that instance that's needed, and then that's repeated over and over and over and over until it becomes so much, right, that we're able to see it as it comes out. Yes? Make sense? If it makes sense, say it makes sense. Keep in mind, and I'll use this as a simple example, we don't see the clouds forming, right? We don't see the water evaporating from the earth, and yet what does it form in the skies? It forms clouds, right? Yes or no? Right? So keep that in mind. That's the same idea, okay? So Benoit Mandelbrot, 15 PhDs, held the chair of Einstein. He discovers that everything comes down to a small fractal. And that fractal is repeated over and over, and that there's an algorithm that you can follow to be able to determine, you know, the size of land masses, the size of forests, not just that. Forestry and biometry, biometry, meaning biological statistics, they use this formula to be able to determine, you know, the biological information, okay, statistical biological information. For example, let's say we go to a forest and we want to measure the distance between one tree and another so that we can figure out how many trees are within that specific area, okay? They use the formula of Benoit Mandelbrot to be able to determine that. Now, what they were also able to uncover is that the distance between the branches of a tree are equal and similar to the distances between one tree and the other within a forest. This was all uncovered by the formula of Benoit Mandelbrot. As well, how many people here like to watch CGI, movies that are affected by animation? Smoke, explosions, oceans, right? Green screen, Avatar, all of that stuff, right? Okay? Or like that Moby Dick movie, I think, that came out a while back with the oceans and stuff like that. All of that, by the way, computationally uses the formula of Benoit Mandelbrot from fractal mathematics. Let me give you another example. The phone in your hand. Hold up your phone. Hold up your phone. Hold up your phone for me. The phone in your hand. If you open up your phone, what you will find in it is a small antenna that's maybe about this big, okay? It's called a fractal antenna. Now, for those of us who are old enough, who remember the 80s, we know that cell phones weren't this big, right? When they first came out. Yes? They would be carried in a briefcase. Seriously, they were carried in a briefcase. Today, if you Google it now, okay, and search phones, cell phones in the 80s, you'll find that it was literally a suitcase. That's how big it was. If you wanted to watch TV, you know that you had to have a huge antenna on the top of your house. Am I right, brothers, or no? Sisters, yes? We used to have huge antennas on the top of our houses. Yes? Okay? Today, we don't need that. Today, we don't need that at all. Why? Because we have small fractal antennas. And so what they did was they took the smallest instance of the antenna, right? And you can Google it, fractal antenna for cell phones, and you'll find it. You'll find the picture. Google it now. While I'm talking, you'll find it. Okay? This is all from the work of whom? Say his name. Benoit Mandelbrot. Okay? So we have Einstein, of course. That's easy to remember. We have Edward Lorenz. Say his name. Edward Lorenz. And we have Benoit Mandelbrot. Benoit Mandelbrot. Now, Edward Lorenz was the father of what's known today as the butterfly effect. Okay? Right? Just so that you know. He's the one that developed that formula. Okay? That one small climatic change in one area of the world will affect the climate in another area of the world. Or what came to be known as the butterfly effect, in that, you know, the movement of the wings of a butterfly on one side of the earth could cause a catastrophe, atmospheric catastrophe on the other side of the earth. Again, this has tasamuh in it. You know, there's a bit of kind of, what do you say, a poetic license, okay? So now we understand then that randomness really doesn't exist. It's affected by other things, outside forces. That coincidence is really not as we have been taught to understand it. And that chaos really doesn't exist. That we live in a world of supreme organization that was organized by, remember, what? The creator of organization, in that proof of organization that we covered, yes, in the second lecture. So you can go back to that. It's recorded. It's online. Okay? Sallu ala Muhammad wa ali Muhammad. And we finished with this. Why is it then that they're pushing, you know, this whole idea of everything's coming out of chaos? Because they want you to believe that nothing has purpose. Because they want you to believe that, you know what, if nothing has purpose, then that means there's nothing that brought this world together. The boson particle. If you read the book M Theory, you'll find that they talk about the boson particle, the Big Bang effect. Us Muslims, we believe in the Big Bang effect. It's in the Holy Quran, right? We believe that the world comes from what? From a reaction that occurred at one point, okay? Now, the question is, just like the water and the oxygen, who made that spark for the water to be created, right? Had to be. So even if you read M Theory, they say, yes, we believe that the boson particles reacted and we ended up with this world, okay? But we do not know what caused the boson particles to react. Now that's true science. Not what the pseudoscience is being pushed on us, that the world came out of coincidence and chaos. Because a true scientist, when he doesn't know something, he'll say, I don't know, I haven't uncovered it yet, okay? And so that means then that we are able to prove that this world does have a creator, is organized, no chaos, no coincidence, all right? And that this is just something that's being sold to us and marketed to us to ensure that we become secularized and consumerized. Sallu ala Muhammad wa ali Muhammad. Tomorrow, inshallah, we'll talk about the theory of evolution, and we'll address that as well as the Human Genome Project. Until then, I ask that Allah bless what little we offered. وآخر دعوانا الحمد لله رب العالمين والصلاة والسلام على سيد المرسلين والفاتحة على أرواح المرحومين مسبوقة مشفوعة بالصلاة على محمد وآل محمد اللهم صل على